In this lesson, we'll begin our review of additional topics and math concepts. We're in the official PSAT practice test, section 3, no calculator. And before I solve the problems relating to additional topics in math, I just want to take a few minutes to review this reference information. You will be given these formulas, this reference information at the beginning of both math sections, section 3 and 4. And you really should know all of these formulas. Obviously, you can refer back during the test, but I just wouldn't spend the time. It also shows you don't have a proficient grasp of these, so you really should know all of these formulas. So the two-dimensional formulas, the area of a circle, rectangle, and triangle, Pythagorean theorem, and then the special right triangles, 30, 60, 90, 45, 45, 90. You should know the relationship of the sides. And then we have the three-dimensional shapes, the volume of a rectangular solid, the volume of a cylinder, and these are new. These did not appear on the test before. The volume of a sphere, 4/3 pi r cubed, the volume of a cone, 1/3 pi r squared times height, and the volume of a pyramid, 1/3 length times width times height. If you notice, both of these are the same as these, but it's 1/3 if they tell you it's a cone or a pyramid. And then some extra information. We know there's 360 degrees in a circle, there's 180 degrees in a triangle, and then there might be one radian question. There are 2 pi radians in a circle. A good strategy with this is if you're converting radians to degrees, substitute a 180 for pi, and that will convert it. So we might see a question like that. Another good strategy just in general, if you're given a shape that is not one of these familiar shapes, let's say you had a hexagon, and you're thinking, well, how many degrees does that have? One formula you should know for any multi-sided shape, the number of degrees is n minus 2 times 180, where n is the number of sides. So this is a 6-sided shape, 6 minus 2, 4 times 180, this would have 720 degrees. Another good strategy, you can always split them up and make them into familiar shapes. You could make this into 6 triangles, so just keep that in mind. All right, let's review question 4. It's not drawn to scale, so you really can't glean anything from the way it's depicted. This triangle ABC is isosceles, with AB equals AC. And BC is 48. The ratio of DE to DF is 5:7. What's the length of DC? So we're told it's isosceles. AB equals AC. So these two sides are equal. That means these two angles here are equal. You should also recognize that both of these triangles are similar because they share this. This is equal. Obviously 90s are equal. These are similar. So similar triangles have the same interior angles, and the ratio of the sides will always be equal. We're given one ratio, DE to DF is 5:7. So this is 5 and this is 7. We're also told the length of DC, all right, this whole length here is 48, and we want to know what length is DC. There's a couple ways to do this problem with any ratio. We're given 5:7. A good strategy, just put those values in. That's a true statement. So this is the bigger triangle. So if you think about the two parts, so we've got a 5 and a 7. The total, if you just add them up, is 12. So the ratio of the bigger triangle will always be 7/12. That's a true statement. Now we're given this whole length, this 48. We want to know what ratio will the bigger triangle have. We know it's 7/12. So you could just take 7/12 and multiply by 48. This is no calculator, so I definitely would recommend reducing this before multiplying it, and then get the answer, which is 28. So let's look at the choices. It is D. Another strategy too, if you just think about this intuitively, remember this is the bigger triangle, and it's 7/12, so it's more than half of the 48. And if you look at the choices, the only one that's more than half is D. It couldn't be C, because that would mean they have equal ratios, and they don't. This is a bigger one, so it has to be greater than half. That's a faster way, but this is sort of the way to solve it if some of these other problems, the questions didn't lend it to that solution. All right, we've got one more question. It's number 18. In the quadrilateral ABCD above, BC is parallel to AD, and AB equals CD. If BC and AD were each doubled and BE was reduced by 50%, how would the area of ABCD change? Now, this is a question where they're giving you some condition about this shape where these different sides are doubled and reduced. We know how the area changes. A good strategy for this technique is to put values in and test it. So one formula that you probably should know, this is a trapezoid. I know that wasn't given. you could have split this up and made two triangles and a rectangle, but a faster way if you know some of the other formulas. So the area of a trapezoid means it's a four-sided shape with a set of parallel lines, and we know that, we're told that. And the formula, it's 1/2 times the sum of the two bases. So here is 1 and there is 1 times the height. So if you know that formula, I think it's going to save time. And what I mean by this is we're given these conditions. One's double, the other's reduced by 50%. It's just put in a value to test it. So here's the original shape and with the formula. So BC, again, you can just put in any value you want as long as you follow the rules. So we're going to say BC, and I'm going to say AD is 6. All right. So again, you don't even have to like solve the whole problem. So it's going to be 1/2. The sum is going to be 10. And for the height, BE, we'll just say that's 3. All right. So you could multiply this out. I would just leave it and let's just compare. All right. Now we're given a condition that we're told that both of the bases double. And so now we're going to contrast it. Here's the original. But if both of the bases double, we know that it's going to be 20. Right? We just doubled 4 and 6, and it's 20. But we're also told that BE, I probably shouldn't have picked 3 because it's going to have an odd number, but it doesn't matter. We're told that's reduced by half. And so we're going to cut this now, this 3, in half. And you can recognize what happens here. All right, this is going to be 30 divided by a half, it's 15. This is 30 divided by half, that's the same. Again, you don't even have to multiply it if you just recognize this formula. Well, we're doubling this component, but we're cutting this one in half, and so there's really no change to this, and the answer is C. But I think knowing your formulas and putting in a value is a good strategy for these types of questions.